Hi, my name is Kishan Agarwal from CSE Section B. Today I am going to present my tech talk of linear algebra and calculus, and my topic is defining differentiation and integration in Z. So let's begin with differentiation. So the process of finding derivatives of a function is called differentiation in calculus. A derivative is the rate of change of a function with respect to another quantity. The laws of differential calculus were laid by Sir Isaac Newton. The principles of limits and derivatives are used in many disciplines of science. Differentiation and integration form the major concept of calculus. So let's see what is differentiation. Differentiation means the rate of change of one quantity with respect to another. The speed is calculated as the rate of change of distance with respect to time. So the speed at each instant is not same as the average calculated. Speed is the same as the slope, which is nothing but the instantaneous rate of change of distance over a period of time. The ratio of small change in one quantity with a small change in another, which is dependent on the first quantity, is called differentiation. One of the most important concepts in calculus is mainly focused on the differentiation of a function. The maximum or minimum value of a function, the velocity and acceleration of moving objects, the tangent of a curve are determined by the differentiation. If y is equals to f of x, that is differentiable, then differentiation is represented as f dash of x or dy by dx. So definition of derivatives. The geometrical meaning of derivatives of y is equals to f of x is the slope of tangent to the curve y equal to f of x at x comma y point or x comma f of x, that is the function value at x. The first principle of differentiation is to compute the derivatives of the function using the limits. Let a function of a curve be y is equals to f of x. Let us take a point P with coordinates x comma f of x on a curve. Take another point Q with coordinates x plus h comma f of x plus h on the curve. Now PQ is the secant to the curve. The slope of a curve at a point is the slope of the tangent line at that point. So see, this is the P point and this is the Q point. P point is x comma f of x and the Q point is x plus h comma f of x plus h. So here it is forming a secant, and if we want to find the slope of that line PQ, so we will find del y by del x, that is f of x plus h minus f of x by x plus h minus x. On simplification, this will give f of x plus h minus f of x by h. So we want h has to be small as possible to get the slope of the tangent. We have y equal to f of x. There is an incremental change in x denoted as delta x. This is very small change. Then there exists an incremental change in y denoted as del y. That is small change in the function. So dy by dx equal to f of x plus delta x minus f of x by delta x. See here, y plus delta x will give function of x plus delta x. So f of x plus del y equal to f of x plus del x. So this will give del y is equals to f of x plus del x minus f of x. So if we divide both sides of this equation with delta x, we get dy by dx is equals to f of x plus delta x minus f of x by del x. As the change is so small, applying the limits we get, if we apply limits, that is del x equal to tends to 0, then we'll get limit delta x tends to 0 f of x plus del x minus f of x by del x, where d by dx is a differential coefficient and it is known as Leibniz symbol. So limit h tends to 0, f of x plus h minus f of x by h if the limit exists. That means if the limit exists, then the function is said to be differentiable. So f dash of x is the first derivative of f of x. The derivative of f of x at a quantifies the change in f of x with respect to x. This process of computing the derivative of a function is called differentiation. Now let's see what is the differentiation formula. So the derivatives of a function are found using the derivative formula as derived in the previous section. That is with this formula. F of x plus h minus f of x by h when limit h tends to 0. So consider the derivative of the elementary functions are remembered as the differential formula. Consider a function y is equals to x power n where n is greater than 0. So then f of x plus del x equal to x plus del x whole power n, and f of x plus del x minus f of x will give you x plus del power x del x whole power n minus x power n. So if we find limit at that point, limit h tends to 0 or delta x equal to 0 tends to 0, we'll get x plus del x whole power n minus x power n by x plus del x minus x equal to limit y tends to x y power n minus x power n by y minus x, that is n to the power of x power n minus 1, where y is equals to x plus delta x and y tends to x as delta x tends to 0. Yes, if we substitute in the equation y equal to x plus delta x as delta x equal to 0, so we can say that y tends to x. So that's why we have taken the value y tends to x. Similarly, we can derive the derivatives of the other algebraic, exponential and trigonometric functions using the fundamental principle of differentiation. So differentiation for elementary functions, like the derivative of constant is always 0. The derivative of constant function is always 0. If y equal to k, where k is a constant, then differentiation of y or y dash equal to 0. The derivative of a power function, that is y equal to x power n, where n is greater than 0, then differentiation of y will give you n into x power n minus 1. Next, the derivative of logarithm functions. If y equal to log of x base to the power base e, then y dash equal to 1 by x. And if we have other than e, that is y equal to log of x base a, then y dash equal to 1 by log of a into x. Next, the derivative of an exponential function. If y is equal to a power x, then y equal to a power x log a. If it is e power x, then the differentiation is same, e power x, y equal to e power x. Now differentiation of trigonometric functions. If y equal to sin x, then y dash equal to cos x. These are the differential formulas for trigonometric functions, and here inverse trigonometric functions. Sin, cos, tan, sec, cosec and cot. Similarly, inverse functions. Now look at the rules of differentiation. If f is differentiable at a point x equal to x naught, then f is continuous at x naught. A function is differentiable in an interval a comma b if it is differentiable at every point in a comma b. So a function should be differentiable at every point in the interval. The sum, difference, product and composite of differentiable functions wherever they are defined are differentiable, and the quotient of two differentiable functions is differentiable wherever it is defined. The differentiation rules are listed below in the table. So as we have seen, constant rule, that is differentiation of constant is always 0. Power rule we have already discussed, that is differentiation of x power n will give you n into x power n minus 1. What is product rule then? Differentiation of f of x and g of x will give you f dash of x g of x plus f of x g dash of x. Quotient rule? Quotient rule means dividing. D by dx of f of x by g of x will give you g of x into f dash of x minus f of x into g dash of x by g of x whole square. Next, the last rule is chain rule. D by dx of f of g of x will give you f dash of g of x into g dash of x. That means we have to first differentiate the external function, then after that we have to multiply or differentiate the internal function. That is chain rule. Now let's see what are the applications of derivatives. In maths, derivatives have wide usage. They are used in many situations like finding maxima or minima of a function, finding the slope of the curve, and even inflection points. A few places where we will use the derivative are again given below. The most common usage of applications of derivatives are: first is finding rate of change of a quantity. That is to find velocity, acceleration, and many things. Using derivatives it will become very easy. Finding the approximation values. Finding the equation of tangent and normal to a curve. Finding maxima or minima and point of inflection. Determining increasing and decreasing functions. These are the few applications of derivatives. There are many applications, but these are the few applications which are given below. Now let's begin integration. What is integration? So integration is a way of uniting the part to find a whole. That means integrating all the parts. In the integral calculus, we find a function whose differential is given. Thus, integration is the inverse of differentiation, as we know. Integration is used to define and calculate the area of region bounded by the graph of a function. The area of the curved shape is approximated by tracing the number of sides of the polygon inscribed in it. This process, known as method of exhaustion, was later adopted as integration. We obtain two forms of integrals, that is indefinite and definite integrals. Differentiation and integration are the fundamental tools in the calculus that are used in solving the problems in maths and physics. The principles of integration were formulated by Leibniz. Let's move further and learn about integration and its properties, some of its powerful techniques. So let's begin. First of all, what is integration? Integration is a process of finding the area of the region under the curve. This is done by drawing as many small rectangles covering up the area and swimming up their area. That means you have to divide the curve which is occupying the area in the plane. We have to divide it into infinitely small rectangles to find the area of that. The sum approaches a limit that is equal to the region under the curve of a function. Integration is the process of finding the antiderivative of a function. If a function is integrable and if it is integral over the domain is finite with the limit specified, then it is known as definite integration. So let's see. If dy by dx of f of x will give you f of x, then integration of f of x will give you again the f of x. So if we are differentiating a function, so the answer which we get, if we again integrate, we get the actual function. So this is the reverse process to convert. If a function is differentiated, then we need to get again the same function. So what we have to do, we have to integrate that quantity or the result of the differentiation. So these are indefinite integrals. For example, let f of x is x power 3 be a function. The derivative of the function will be 3x square, and the antiderivative, again if we find that the differentiation of 3x square, will get the function itself, that is x power 3 or x cube. So thus we find that the derivatives of f of x equal to f of x. However, the antiderivative of f of x are not unique. The antiderivative of f of x is a family of infinitely many functions. In fact, there exist infinite integrals of the function because the derivative of any real constant c is 0. And we can write as integration of cos x dx equal to sin x plus c, because constant, when we are differentiating, we will get 0. So while integrating, we have to assume some constant which we don't know. It is the rule of integration to add an arbitrary constant c from the set of real numbers. It may be anything. Thus we conclude that if dy by dx equal to f of x, then we write y equal to integration of f of x dx, which is read as integral of f of f with respect to x. Okay. Now we'll see the theorem. If f of x is a particular antiderivative of f of x on an interval I, then every antiderivative of f of x on I is given by integration of f of x dx. Will give you f of x plus c. So here integration of f of x dx represents the whole class of integral. So it includes all the real values in c. So c is arbitrary constant, and all the antiderivatives of f of x and I can be obtained by assigning a particular value to c. So we have to take the different values of c to get the actual function. Here f of x is the integrand. The variable x in dx is called the integrator, and the whole process of finding the integral is called integration. The sign stands for the sum. So the following figure shows the integration and differentiation relationship. That is, if we differentiate a function, we get in, and then again if we integrate, we get the actual function. So 3x square, if we integrate, we will get x cube. If we again differentiate x cube, we will get 3x square. Now, integration and inverse process of differentiation. We are given a derivative of a function and are asked to find its primitive, that is the original function. Such a process is called anti-differentiation or integration. If we are given the derivative of a function, the process of finding the original function is called integration. The derivatives and the integrals are opposite to each other. Consider a function f of x equal to sin x. The derivative of f of x is f dash of x, that is cos x. We say that the function cos x is derived function of sin x. Similarly, we say that sin x is the antiderivative of cos x again then. Okay. Now, what are the rules of integration? We'll see. We already know that the formulas of derivatives of some important functions. Here are derivatives and their corresponding standard integrals of few functions as the integration formulas. See. So these are the formulas of integration and differentiation given. We can go through it once. So there are certain rules defined for finding integrals. They include sum and difference rule. That is, integration of f of x plus g of x will give you is same as integration of f of x plus integration of g of x. Similarly, in subtraction, if we find the integration of f of x minus g of x is same as integration of f of x minus integration of g of x. Next, power rule. If you are finding integration of x power n dx, it will give you x power n plus 1 by n plus 1 plus c. Next comes to exponential rule. Integration of e power x is also same. Integration of e power x is e power x. Whereas if we are finding integration of a power x, then we'll get a power x by log a plus c as usual. Log of x will give you x log x minus x plus c. Next, constant multiplication rule. Integration of a dx. If it is a constant, we can remove it outside of the integration, that is a integration of dx will give you x, ax plus c. Reciprocal rule. Integration of 1 by x will give you log x plus c. Now, what are the methods of integration? Methods to find integration. Sometimes the is not enough to find the integral of some function. There are additional methods to reduce the function in the standard form to find the integral. Prominent methods are discussed. See, what are the prominent methods which we use to find integration? Are decomposition method, integration by substitution, integration using partial fractions, integration by parts. So these are methods which we use to find integration. Now, what are the types of integration we see? Indefinite integrals. Indefinite integrals is the integration of a function without any limit. Integration is the reverse process of differentiation, as we know, and it is also called as antiderivative of the function. The indefinite integral is an important part of calculus, and the application of limiting points to the integral transforms it to define integrals. Integration is defined for a function f of x, and it helps in finding the area enclosed by the curve with reference to coordinate axis. So see here it is given. See, indefinite integral means without any limits. We are finding the integration. We are finding just the general integration. That is, if we take x power n dx, we will get x power n plus 1 by n plus 1 plus c. This is the indefinite integral. Now we will see definite integral. Definite integral helps to find the area of the curve in a graph. It has limits which are the start and the end points, within which the area under a curve is calculated. The limit points can be taken as a comma b to find the area of the curve f of x with respect to the x-axis. The corresponding expression of the definite integral is integration of a to b f of x dx. Integration is the sum of areas, and definite integral are used to find the area within the limits which are given. So especially definite integral is used to find the area of circles, parabolas, ellipse. Okay. Now, which we have seen already, what is definite integral? It has limits like a to b to find the area within the limits. Now, what are the difference between indefinite integrals and definite integrals? The indefinite integrals is used to find the integral of the function, and the resultant expression represents the area enclosed by the function with reference to one of the axes. A definite integral has a definite value. The definite integral is represented as, we have already seen, integration of a to b f of x dx. So it has lower limit and upper limit, whereas indefinite integral does not have any limit. It will be the general integration. So this is the difference between indefinite integral and definite integral. It has no range, but it has particular limits, that is a to b. Now further, the numerous formulas and theorems used to across. See, we can find the indefinite and definite integrals with different methods using wherever it is applicable. Now we'll see differentiation and integration in Z. Why we need the Z? We show how familiar mathematical concepts from differential and integral calculus can be represented in the Z specification language. Digital computer system involves hardware devices and software variables that can be adopt a limited range of values only, and may be temporarily inaccessible or ill-defined. Emphasis is therefore given to supporting discrete range types and partial functions. So, calculus is a study of change and motion, and a cornerstone of modern mathematics. It provides methods for solving two large classes of problems. Differential calculus allows us to find the rate at which a variable quantity changes, given its characteristic function. Integral calculus allows us to find the function defining a variable quantity, given its rate of change. Considering the importance of these concepts in the physical science, it is surprising how little they have been used in the computer science. That we already know. Yeah, it is very little. The calculus is very little used in the computer science when compared to the physical science. In the past, those specification languages most widely used in computing have concentrated to finite state machine modeling only. Nevertheless, languages intended to support the development of embedded systems with real-time constraints are inevitably challenged by the need to model both continuous physical processes as well as discrete computer system behaviors. Differentiation and integration of total real-to-real functions are, of course, familiar concepts. However, when modeling the state of digital hardware devices or the values of computer program variables, we are required to employ some less common definitions. We must account for the fact that digital components can adopt only a finite set of possible states or values. Therefore, we want definitions that are applicable to discrete range types. Similarly, digital components may become temporarily inaccessible or ill-defined while changing values. Therefore, our definitions must accommodate partial functions. We do not, of course, claim to make any improvement to the thoroughly explored mathematical discipline of calculus, nor the Z specification language itself. However, by showing how concepts from calculus can be represented in a Z-like notation, we allow programmers to use calculus operators in Z specification with confidence, secure in the knowledge that formal definitions of there exist. Also, the definitions provide typing information for the operators essential for supporting their representation in formal method tools. Thank you. So this is what the presentation which I have made on differentiation and integration using Z or in Z. Thank you.